Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Module 9, Address Resolution. So what we're going to be talking about in this is talking about how we obtain an address when we're not sure what it is. So we're going to be looking at both MAC and IP addresses and kind of compare the roles. We're going to describe what address resolution protocols are, ARP, and we're going to look at the IPv version 6 equivalent for those operations. So, MAC versus IP. Again, MAC addresses are our layer 2 physical addresses. Those are typically the MAC address. They are used for NIC to NIC communication on a LAN. That is what is going to be sent and scrubbed each hop. Remember that a hop is between a layer 3 boundary. The layer 3 information, the IP, is what we put on packets, will not be scrubbed. That is what actually allows for end-to-end communication, leaving the network. So layer 2 addresses are used to deliver frames from one NIC to another on the same network. If we need to send outside of our network, we will use a frame to send to our default gateway. And then the default gateway will continue on that path. So when the destination IP address is on a remote network, what do? Again, we will send a frame to our default gateway. Our default gateway in this example will be R1. R1 will take and scrub the information. We'll look at the IP information, and then we'll replace the frame using its MAC address and using the router 2 gig 001 interface as the destination MAC address. That way, we can forward that frame on the wire to router 2. Router 2 will receive that frame, will strip it away, look at the layer 3 information, and then repeat the frame process to the destination of PC2. So what happens if we don't know it? What happens if we don't know the MAC address of the next device? Well, that's where ARP comes into play, assuming that we're using layer 3 IPv4 addressing. So ARP is used by IPv4 to associate the IPv4 address with a MAC address. That way, we know how to get from source to destination, even if the MAC addresses are unknown. With IPv6, we will use ICMP v6 to associate IPv6 addresses with MAC addresses. So there is no real ARP v6. That's what the purpose of ICMP v6 is. We do have Packet Tracer Labs for just that. Moving on, we have, again, ARP overview, address resolution protocol, so we can understand how it works. So if a device uses ARP to determine the destination MAC address of a local device when it knows the appropriate IPv4 address, essentially I will send out a broadcast, who is this, or what is the MAC address of this IPv4 address, who is this? And ARP will be sent, and the appropriate response will come from only the device, the end device that has that IP address. Everyone will get it, but only the appropriate device should respond. This allows for maintaining an address table, an ARP table, for MAC addresses and IPv4 addresses. The ARP function is again to send a frame to a device that will search for the ARP table of the destination. Essentially, again, we'll send out a broadcast, who is this? We can either look at tables of ARP requests, or we can send the broadcast to everyone, and only the end device that has the matching address, logical address, IP address, should respond. If the destination IPv4 address is on a different network, the device will search the ARP table for the default gateway. So if we need to send it outside of our network, we will be figuring out the MAC address for our default gateway, and then we will go from there. If there is no ARP table entry, then the device will send an ARP request. So we try to look at our table. That will be the table that we have, that the current end device actually has for all of the MAC addresses and IP addresses for the network. If it's not on there, we will send the ARP request. Realistically, these tables are updated fairly frequently, but it's just like having a MAC address table, except we're tying in layer 3 information. Videos for these are done in a separate lecture. So how do we remove entries from that ARP table? We can actually look at our command line, and we can actually let them age out. The duration of the ARP cache timer will be different depending on the operating system, Windows 10 versus Mac OS X versus Linux, or the variation of Linux that you're running. ARP address tables can also be removed manually by administrators via command line. So if we're looking at our command line via router, the router will have an ARP table. If we are looking at our ARP table on individual devices, we could do an ARP TAC-A, and that will be at a command terminal. That allows us to see our IP addresses and physical addresses that have been learned. Again, if we're on Windows 10, at a command line, ARP space TAC-A will bring up your ARP table. So what are some of the issues with ARP? Well, ARP requests are received and processed by every device on a network. Excessive ARP broadcasts can cause the network to slow down. So ARP replies can also be spoofed. So this allows threat actors to do ARP poisoning. Enterprise level switches will include mitigation techniques so that ARP poisoning and ARP attacks cannot occur. So we actually do have a lab examining ARP tables in Packet Tracer. Moving on, we have copper cabling for some reason in this chapter, but that's mainly to look at how we deal with IPv6 neighbor discovery when we don't use ARP at the LAN level. So essentially what ends up happening is, with IPv6, we will use a neighbor discovery protocol, and this ND protocol allows for address resolution. It provides the ARP functionality, router discovery, and redirection services. ND actually allows for neighbor solicitations using ICMPv6, and it also will use neighborhood advertisements to use these messages to send information to device. That actually is what allows our address resolution, is the neighborhood advertisements. Basically, each device will advertise their information on the network, not needing to rely on address resolution protocols with IPv6. So, IPv6 actually just has this functionality built into it. We also have router solicitation messages and router advertisement messages, and these will be used to allow for messaging between devices and the routers. So how do IPv6 devices learn about the routers? That's going to be router solicitation messages, and the routers will send router advertisement messages. So how does this work? We can actually send ICMPv6 neighbor solicitation messages that will basically say, hey, this is my IP address, and it will say, what's your MAC addresses? And that's how it learns. Responses to NSs are the NAs, neighborhood advertisements. And that will be, this is my IP address, here's my MAC addresses. So NS's are our broadcasts, requesting our MAC addresses, sending our IP addresses, and NA's are responses. Here's my MAC address, here's my IP address. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.